Might want to slow down. Yep, mic is, ooh, good question. Should be on, because I was, yeah, it is. And the battery's actually working. I figured out the other day it wasn't that the mic wasn't on, it's that the battery that they gave me from the office, they were dead to begin with. Oh. It's kind of a bummer, but that's all right. I have new batteries, now it's working. Okay, here we go. For our basic sinusoids, basically we're talking about sines and we're talking about sines and cosines. And sines and cosines, do you remember how many key points they have, guys? 5, which is way harder. And with the whole like cyclic thing, it keeps on going and going and going. It's way harder than an e to the x graph, or it's way harder than a parabola, or it's way harder than an absolute value. Because there's a lot more going on. Sine starts in the middle, and then goes maximum displacement, middle, minimum displacement, middle. Those aren't holes, sorry. My marker just was funny. That's going to be a sine curve, basically. And then every single wave just keeps going, right? Just keeps going. Cosine doesn't start in the middle. Cosine starts at the top. And this has to do with the unit circle because cosine starts at, like our cheater chart, cosine starts at 1 and goes down to root 3 over 2 and then root 2 over 2 and then 1/2 and then 0. Starting at 1, technically at 0 when x is equal to 0, if I was to do it that way. This is a normal cosine, right? Going to 2 pi. Cosine goes from 1 to root 3 over 2 to root 2 over 2 to 1/2. Actually, it should be 1 to root 3 over 2, root 2 over 2, 1/2, and then 0. And that's the first quadrant. Then it goes to the second quadrant, negatives. Then the third quadrant, negatives. Then the fourth quadrant, positives. So cosine starts at the top and goes down. So it's going to be decreasing. Sine, though, if you remember this cheater chart, if you remember the unit circle that way, sine starts at 0 and counts up. 0 to 1/2 to root 2 over 2 to root 3 over 2 to 1. Sine counts up 0 to 1/2 to root 2 over 2, root 3 over 2, 1. And then second quadrant, it comes back down to 0. Third quadrant, it goes negative. Fourth quadrant, it finishes off negative back to 0. So these waves, even though they don't look at all like the unit circle, actually the y values are coming from going through quadrant 1 and 2 and 3 and 4. However, that's only for basic sine and basic cosine. We can have transformations of all shapes and sizes, and we just started talking about them yesterday and said, hey, you know what? I could tell you, take those 5 points and shift them and then stretch them and then compress them and then, try to figure them out. Or I can give you some tricks for how to graph sinusoids. So here are the tricks. This D guy, always called the sinusoidal axis. He's the middle. Amplitude, how high the wave goes, how low the wave goes. If you need to amp up your music, you're trying to make the waves higher, the sound waves higher to make it louder. Amplitude, how high, how low from the middle, from the sinusoidal axis. B is going to be, actually B is a little weird. B is the horizontal dilation. So it's the horizontal dilation. The weird thing is, though, remember horizontal? It's always backwards what you think. If there's a minus inside, you're actually going to the right. And if there's times a whole number, you're actually cutting it into a fraction. Or taking a fractional piece. So it's the horizontal dilation by the reciprocal, 1 over b. And then c over b, which is what you see over here, or what you could find with the c and b up here. C over b is going to be the initial point. The initial point. And about the initial point. For a sine function, the initial point is going to be at the middle, which sometimes is 0. At the middle, which sometimes is 0, but we just said the middle could change. So at the middle is going to be the d. That's the y value. Sometimes it's 0 on the axis, and sometimes it's not. And then c over b is going to be your x value. For cosine, though, you're still going to have the c over b being the x value of your initial point, but cosine doesn't start in the middle. Cosine starts at its max displacement. So sine and cosine, both the basic graphs start at 0. But sine starts in the middle, which we said is the sinusoidal axis. Cosine starts away from the middle. And technically that away is the amplitude. And for a basic cosine, the amplitude is just 1, because there's only a 1 in front. So we're going to say d plus a. the middle plus the amplitude. That's just a little hint. That's just a little hint. Now this doesn't get you the entire graph, but this kind of gets you where to start. If you can find the sinusoidal axis, figure out how high, how low, and figure out where the initial point is, you know where to start your wave. Then you just need to figure out where to go from the first point. And we'll get to that in just a second. Amplitude, we already said how high, how low. We're going to go ahead and call that our A. Ooh, sorry, it's up a little high. Let's bring him down. Nope, that's all right. I'll go steal him. There he is. Okay, our amplitude's going to be our A. How high or how low? Technically half the distance between the max and the min. How high or how low? And you see him right here in that the cosine needs to start wherever the middle is plus A. A removed away. The period, now this one's a little bit harder. The period is how long it takes. That's not where it starts. That's not like the initial shift. The period is how far it takes or how long it takes for one wave to complete. Sine usually takes 2 pi to complete. Cosine usually takes 2 pi to complete. They both do, but if there's a stretch or a compress, that's going to change. If there's a stretch or a compress, that's going to change, and it's going to change by this guy right here. So period is going to end up equaling, P is going to end up equaling horizontal dilation times 2 pi. Or some people would say 2 pi over b. It kind of depends on what b is. If he's a nasty fraction, it might be easier to do 1 over. Because you don't like dividing 2 pi by a fraction, like 2 pi divided by 1/2. Ew. But 1 over 1/2, the reciprocal of 1/2 times 2 pi, that's easy, but that's okay. Either way, 1 over b times 2 pi or 2 pi over b, that's the period. That's how long for one wave. Or we could say for one cycle. From beginning to end of, oh, sorry, I just put it right here. Beginning to end of one cycle. So for one entire wave, for one entire cycle. So technically, we can figure out the final point, if this helps, with the period. We can figure out the final point with the period. For a sine curve, the final point, like the very last one, if you look at the sine, doesn't it come back to the middle at the end? So back at the middle, that would be back at D, the sinusoidal axis. And now it's gone from the initial point, it's gone the period. It's going to be back in the middle at the end of one wave when it's moved, P or period, the period away from C over B. And the cosine curve, he starts at C over B also, and at the end of a period, he's going to be back at the top, right? So back at D plus A. Now guys, these really aren't things to memorize, but they are kind of just a few little formulas. So if you get a little stuck, you can be like, okay, wait a minute, how do I find the first point? How do I find the last point? And hopefully it'll become a habit to where it's easier, and you're not having to like look at any formulas in order to graph. At least not many formulas. Then the last two that you guys wrote down, translations and phase shift. Oh my goodness, I already gave you the phase shift stuff. That's okay. Translations. Vertical shift, you're going to shift the sinusoidal axis. SA is what we can call it, shortcut form. That we already called. That's a vertical shift. Horizontal shift is where the phase shift comes from, the beginning of the cycle. And as we already said, the sine always starts in the middle, which we could call equilibrium, like if the water was totally smooth, that's the middle. Then as soon as you drop a stone, it displaces and then it comes back up. That little ripple is the wave. The still, the smooth, the equilibrium, that's the middle, y equals d. Cosine curve. That could be an example of if you had a spring. If you had a spring, and if you were to pull it down, well, it's at rest. If you were to pull it out, we'll say it that way. If you were to pull it out, it starts displaced. It doesn't start at equilibrium or at rest. It starts out here, and then it goes boing, 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 boing. Anyway, a few different examples of where sines and cosines and the cyclic, this wave-like nature can be used to model in nature, etc. will begin at plus a. So let's use all this stuff to try to figure out, okay, what are we doing? We're going to come back to this picture, and I'm going to show you guys how it works, but basically, we'll come back to it, don't worry. Basically, if I can get you the middle line, D, and if I can get you the top line of how high this goes, plus a, and technically the bottom of how low this wave goes, minus a. So we end up at y equals d minus a, and y equals d plus a. Then wherever we are, whether this is up, down, whether the xy is down here, the xy is up here, wherever this little guideline appears, you're going to be putting your wave right in here. It's just going to shift around, and it might stretch a little bit, and your wave might go out or in. We're going to go ahead and try to figure out where is that initial point. Let's pretend it's a sine for a second. That's going to be our c over b of wherever we are. Then we're going to try and take from that c over b, we're going to add a period to get to our c over b plus p. And that's good from beginning to end. We're just pretending it's a sine curve. I'm just choosing a sine for right now. From beginning to end. But guys, it's not just 2 points to a wave. What do we need? 5 points. Well, how do we do that? Well, can't we cut this distance in half, figure out a half period and where that's going to lie? Right? And can't we cut the half in half and figure out where that one's going to lie? Oh, wait a minute. We talked about 2/4. So if we can just go by 4th p's, adding 4th p's every time, we can just say here to here to here. Haha, I'm done. Put little arrows at the end and you're done. There's your wave. Putting all of these different pieces together at once. So let's go ahead and try some examples. Let's start with a really basic one. One that technically you would be able to use without all these tricks. What if I was to give you, graph the sine of x over 2? Sometimes once you learn the trick, the easy ones get hard, which is kind of sad, but helpful for the hard ones. For instance, if I were to ask you, hey, what's d for this function? Y equals sine of x over 2. Who's d? There you go. You might need to rewrite it just a little bit to see all your pieces, like d is 0, a is 1. This is of a sine curve. I have 1/2 x minus 0. Do you see how I identified all my different pieces? Who's d? He's not there. Fine, 0. Who's a? Well, everything's multiplied by 1, I guess. Okay. Who's b? Well, what is the x? It's divided by 2. Oh, that's times 1/2. Who's c over b? Well, there's nothing there. Okay, fine, 0. Bless you. So here's how this guideline works. It says find, number 1, find the sinusoidal axis. Find the d. I'm going to label that as step 1. Y equals 0 is the middle. Y equals 0 is the middle. Nothing's moved, nothing's shifted. It's at y equals 0 as it should be. That looks like a 6. I really apologize. I meant to say step 1. Graph your d. Step 2, I would say, is mark your amplitude. How high, how low? So go up 1 to how high this can go, and go down 1. From the middle, wherever it is, go up 1, go down 1. Then I do longer dashes to show the top, and shorter dashes to show the bottom. Hey, wait a minute. Do you guys ever remember lines way back when to learn how to do something? Looked kind of like that. Handwriting paper, remember? And they had the A's, the little A's, and the big A's. And you used to have those like notebooks up, those kinds of lines for writing. You were keeping everything on it, right? We're kind of doing that, but with waves. We're kind of doing that, but with waves. Yeah. Yeah, we haven't actually had to deal with it yet. It's because the amplitude itself is how high, how low. Us adding and subtracting in like a positive and negative position. When there's a negative in front, it's actually a reflection. So it doesn't change the how high, how low. The how high, how low is still determined by this number itself. It's not even determined by this sign. So the negative would be a reflection from amplitude. Now as we go to graph it, we know that sine starts in that, wait, we need a first point. Without a first point, we won't know what to do. So our first point, our initial point, I would say go look here, number 3, at where your first point should be. When you do number 3, you also kind of have to consider both who is this guy and what is that guy. Because sine's initial point is going to be in the middle at C over B. So C over BD is going to be, oh, okay, C over B, 0, and then D is 0. Okay. 0, 0. I'm starting at 0, 0, just like I always do. There was no horizontal shift, so my first point didn't go anywhere. There was no vertical shift, so my sinusoidal axis, my middle, didn't go anywhere. So now what's the last thing? We did the sinusoidal axis, the amplitude. We considered our first point, looking at sine and looking at the C over B. Last but not least, it's weird, we come backwards and we look at the 1/2. And we have to take the 1/2 off to the side. Step 4 is weird, because step 4 says we take the 1/2 and we plug it in the period formula. Period says 2 pi over 1/2. Oh, that's gross. Oh, the reciprocal of 1/2 times 2 pi. Maybe that's easier. I know from beginning to end, I need to go 4 pi. And some of you might want to do this first. 0 plus 4 pi is just 4 pi, so that's where I'm going to end. And maybe you can say, hey, half of that's 2 pi. Sweet. 0 plus 2 pi is 2 pi. Half of that's 1 pi. Sweet. 1 pi is going to be up at the top. Half of that's 3 pi. Sweet. That's going to be in the bottom. Moving the direction that you know your sign points move. Middle, top, middle, bottom, middle. But for others of you, when the numbers get gross, maybe you won't want to have to cut this in a half and then into a fourth and then add it every single time. Maybe it would have been easier to think of your quarter cycles. And your quarter cycles say, hey, for every key point, just go and count by pi's. So 1 pi got it, 2 pi got it, 3 pi got it, 4 pi done. Dun, 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 dun. But that was an easy one. This was a sine curve that just had a horizontal stretch by 2. Everything stayed the same, going up 1, down 1, starting at 0, 0. It just went to 4 pi instead of 2 pi. So what's different with, whoo? Yeah, basically, huh? A little bit harder. But there's still something that hasn't changed yet. There's still something that hasn't changed yet. We're going to rewrite it in just 1 second, but I want you guys to look at this equation and then look at the one that we were just using a second ago. How might you rewrite this guy to be ready to figure out who's my D, who's my A, who's my C over B? What are my quarter cycles? Well, what's my period? And then what are my quarter cycles? Trying to condense them, but you guys didn't eat enough. Eat for effort. How's the frosting? Not too bad. Kyle, go ahead. That's a great idea. I would think first you should write a 0 plus. What do you guys think? Well, actually it's a 0 minus. But Kyle's idea of taking out 2 pi, do you guys see why he said that? If you look at your formulas, you can either leave the B in, and that's B and that's C, or you can just factor out the B. And it's kind of a little bit nicer. Now when I pull out a 2 pi, isn't there just a 2 left inside? Do you guys agree? Okay. But now I can see my D, I can see my A, I can see my C over B, which I have to look at my cosine and my C over B. And I'm going to take away my 2 pi. But just in case you guys get a little bit confused, depending on what the homework asks, real quick, D is equal to 0. A is equal to positive 3. We'll get back to that in a second. C over B is equal to 2, which you could have literally done C, 4 pi over B, 2 pi. Look at those formulas. There's 2 different variations. And then my period, well, we'll get back to that in just 1 second. Okay, so my D, 0, has shifted up or down at all? Nope, the middle is still right here on the x-axis. Okay, but how high and how low is my wave? 3 up from there and 3 down from there. The negative doesn't change how high, how low does this go. Now just to make it a little bit more obvious from the one on the page before, let me make these tick marks a little bit bigger. Because this should be stretched. Sometimes we make the scales like we squish in more so you can't really tell, but it should be stretched. So I've done my middle, I've done my top and bottom, my amplitude. Now come over here 3 to your initial point, 4 cosine. You can look over there on the board if you want. 4 cosine, negative 2, x minus c over, oh, negative 2, it shifted left 2. And the cosine doesn't start in the middle, it doesn't start at D, it starts maximally displaced, aka D plus A, so it's going to start at 3. If you want to know the formula, it's C over B, D plus A. Or if you want to think about it, cosine starts at the top. So I'm going to go ahead and put at negative 2. Now here's a little bit of a struggle. Just a warning for really, really, really nasty problems. You might not want to just go making the tick marks 2, because the tick marks might want to be something else besides 2. And you won't know that until you answer your last number, your period. Because your period says, I want to go by this one, wanted to go by pi's. 1 pi, 2 pi, 3 pi, 4 pi. Why? Because of the first point? No, because of the period and the quarter cycles. So hold on, maybe don't do the negative 2 quite yet. Come over and ask yourself, what's my period? Well, my period is going to be 2 pi over b. What's 2 pi over 2 pi? 1? I'm supposed to finish a whole wave in 1? So if I go making like negative 1, negative 2, I'm supposed to fit a whole wave in one of those? That's a bad idea, right? Don't go do that. If I need to make a whole wave fit in 1, don't I need to maybe go by 1/4 on my graph? Wait, why 1/4? If my period is 1, that's good and all, but we're going to have to move by quarter periods or quarter cycles, which will be 1/4, right? So I'm going to go negative 2 because I have to. But I'm going to go in fourths to negative 1 and then in fourths to negative 2. Because when I come over here to negative 2, and I put my first point, this is in the way. When I come over here to negative 2, and when I put my first point at negative 2, 3, that's good and all. But in just 1/4, I'm going to have to be down here in the middle. And in just 1/4, I'm going to have to be down here. In just 1/4, I'm going to have to be back up. And in just 1/4, I need to complete one whole wave in 1 unit. Which is so different than these guys that were measuring by pi's. Because this one, it took 4 pi. 4 times 3 is like 12-ish. 12-ish, 13-ish. Took 13 or 12 to get this whole graph over here. This one only took 1 because of this B. If you want to keep going, you totally can. Just keep on going through the pattern. Middle, down, middle, top. There's another one. Could you theoretically try to kind of keep going? Yes, but careful. Make sure you're going all the way down to the bottom, keeping it within those handwriting lines, or I should say sinusoidal lines. Now it just got nasty because it got double. But do you guys see what I'm doing? So to be honest, even though I kind of start graphing a little bit before I've solved for everything, just a warning, when it comes to actually marking x's on the x-axis, you might not want to just look at this. You might want to look ahead and get all of your numbers first. Because if I hadn't figured out earlier that I was supposed to be going by fourths, I could have done a lot of damage getting set up right here. Negative 1, negative 2, I'm ready. Oh, no. There you go. Tony, what's up? Yeah. Because it's a cosine curve, and cosine curves don't start at D or don't start on the sinusoidal axis. They start D plus A. They start removed. And so looking at our graph, our cosine starts or has a height of 3. And Tony, I just saw what you meant. I just saw what you meant. I went fast and I didn't pay attention. Hey guys, was there something that we were supposed to ignore till later? What? Remember, we ignored the negative because we said amplitude doesn't need a negative, and it doesn't need a negative. But here's the problem. Oh, what does a negative do? So pause. Keep what you have. Keep what you have. And I want you to label what you have as, ready? Label what you have as positive 3 cosine of 2 pi times x plus 2. But then I want you in a different colored pen to come to the example, circle the negative. And I'm going to actually do it in a different color than blue because I've been using blue. Circle the negative and say, what's the only thing that changes with a negative? The only thing that changes, wait a minute, we know this, a negative on the outside is a reflection, and a reflection how? A horizontal reflection or a vertical reflection? So instead of going up to 3, what should we have done? The initial point for the negative, the only thing that changes is going to be -2, -3. And then I still come to the middle, to the top. Everything just flips. Actually, it might look pretty cool when you guys are done. It's going to be the exact same thing, just the vertical reflection. So what we graphed was good, but it was good if it was a plus, and it's not a plus, sadly. It's a minus. Vertical flip, there it is. Thanks, Tony. Totally forgot there was a minus. I was in the zone. All right, let's do another one. You guys see how really, though, we're following the same procedure every time? Just we're seeing funny things like, there's a negative. There's numbers inside. I like this problem, but I'm going to change it just a little bit to make it a nice one to end with. We might be able to do one more after this, but just in case we can't. Let me make this a nice one to end with. What if I was to do... I know it is kind of, There you go. Change the problem just a little bit, right? -2 pi. Right, -2 pi. Okay, we want to rewrite this guy. For the most part, he's good, right? He has there's a D, there's an A, there's a cosine of t minus... Okay. What do we have to take away to get t by itself? Not just pi. Pi over 12. We're going to have to pull out a pi over 12. And when we pull out, don't we divide? Factoring is dividing. So when we divide, you can think of it as we're pulling out a pi over 12. And as we do, we're going to need to multiply by 12 over pi. We're going to need to multiply by 12 over pi. When you factor, you divide. Dividing is multiplying by the reciprocal. Why am I showing you this? Because it's really hard to divide 2 pi by pi over 12. But it's not so hard to multiply 2 pi by 12 over pi. And you end up with 24. You end up with 24. 24. It's okay. Let's figure out what we have. So we have a d of -3, right, guys? Okay. So d equals -3. We have an a of 5. I'll put it together in a graph in 1 second. Where do we go after d is the middle? That's how high, how low. Now where do we go? Good. Now we come over here. We think of cosine and we think of 24. Now, hold on, pause. Let's think of Tony, how we saved this on the last problem. When I go to do the cosine's initial point, which is c over b and d plus a, am I allowed to go up to a, or has there been a flip? Has there been a flip? No. Okay, good. So I'm adding a, not subtracting a. I'm adding a. Okay, cool. So then d, well, c over b we already see is 24 minus a positive 24. D plus a is going to be -3 plus 5. That's going to be 2. And then period. That's our step 4. Period says 2 pi over pi over 12. Ew, gross. I think I have reciprocal of times 2 pi, which is, oh, hey, that's 24 also. Which means our going to go by, if we're going quarters of 24, what would that be? 6s. From all that information, guys, I think I'm going to want to make a graph that goes pretty negative, but also goes a little bit positive. Now, question, why am I going to -3 and to 2 and to -4, 5, 6, 7, 8? Why -8? What am I doing? Isn't this my sinusoidal axis? Don't I have to go up 5, which would be to 2? And don't I have to go down 5, which would be -8? You guys see what changed? This little sinusoidal axis moved everything. So I had to go down 3. Now I had to go up 5 from that, down 5 from that to get my wave all set up and ready to go. I need to start at 4 and go by 6s. Uh-oh, I'm going by 6s, huh? All right. 6, 12, 18, 24. Oh, that's way too narrow. 6, 12, 18, 24. 6, 12, 18, 24. Okay. So I have 6, 12, 18, 24. Another 6 from that would be 30, 36, 42, 48, right? Why'd I go so far? Well, don't I have to start at 24 too? But how did I know to go by 6s as my tick marks? Because my quarter cycles are 6s. So I can go to 24 and say, haha, there he is. And then all I need to do is go over 6. Wait a minute. Cosine starts at the top, and where did, as long as it's not... Oh, sweet. Haha. So here. No. Where's the middle? It's not on the axis anymore. Where's the middle? The sinusoidal axis. I have to come down here when I went over 6, and then go over 6 more, and now I'm down here, and go over 6 more, and now I'm back here, and go over 6 more, and now I'm up here. There he is. And guess what? You would get a pretty good picture in your graphing calculator as long as you were in radians and had your window zoomed out to go all. Window wasn't set to here. Well, hold on, but wait a minute. I can go backwards 6 and backwards 6 and backwards 6. Oh, nope, I did it again. I went to the x-axis. It's a struggle. I'm repeating the mistakes I always grade. Back 6, there we go. Back 6, back 6. You can go backwards too when you do your waves, guys. Now there are some homework helps we didn't get to. So we'll see how you guys do tonight. When you get to one that's drawn for you, and you have to make an equation. What is D? What is A? Is it a sine or cosine? If so, where does it start? And guess what? Every curve could be written as a sine or cosine. If you want a challenge, do both. Bye, guys. See you later. Alligators. After a while, it's crocodiles. If you want a cupcake to go, I'm sure Jaden and her mom would not mind.